A ball with a momentum of 6 kg meter per second strikes a wall at an angle of 30 degree and it reflects at the same angle. Calculate the change in momentum. Okay, so we'll assume that there's no energy lost and everything remains the same. Let me explain what I mean. So what we have here is a wall. And say we have an object striking at 30 degree with the wall and it will reflect back with a similar angle, something like this. So this is 30 degree and this is 30 degree. So this is coming in with 6 kg meter per second momentum. And it will bounce back since nothing else is given. We'll assume that it will bounce back with the same momentum. Okay, in terms of magnitude. So calculate the change in momentum. So we know the change in momentum, since it's a vector quantity, it is not just the zero over here. It will be something else because there is change in direction as well. So let's have a look. So when you finish the problem, you will understand this. So I can't make the point now. First, there are many ways of doing it. I'm going the lengthy version. I'm taking up the lengthy version. So first is I'll talk about before strike. Before it strike the wall. So we have P of I comma x. So momentum along the x-axis would be positive 6 into cos 30 degree, cos 30, right? And this will be cos 30 is half, no, root 3 by 2. So this will be 3 root 3. Okay, so that would be your x component, while your y component, since it's coming down, so it will be negative of 6 sine 30. Okay, sine 30, correct. This will be minus 3 kg meter per second. Now let's look into after striking the wall. So we have P initial, this is final along the x-axis will be, see, this will remain the same, 3 root 3 kg meter per second, while P of final along the y-axis will be the same but in the positive direction. So this will be 3 kg meter per second. Now we are looking at change in momentum, which is Pf minus Pi, which will be equal to Pf will be 3 root 3 I cap plus 3 j cap minus 3 root 3, what is this? Yeah, plus itself, I cap minus 3 j cap. So if we resolve it, I will get 6 j cap. So that is your change in momentum. Can you see that? Even though we ended with same magnitude over here. So we have the expression to be something else altogether, right? Change in momentum is 6 j cap. Okay, so don't get confused with 6 over here. There's a lot happening. So when we take different values, we'll get to know. So calculate the change in momentum. So in terms of magnitude, so this is in terms of, in vector representation, this will be just 6 kg meter per second. Let me write with the same color. Okay, yes, you got the difference. So it won't be a simple straightforward thing. There is a bit of calculation. Of course, we can do this much faster, and you can use quite a few commonsensical point, because x component is not changing. The momentum along the x will remain the same, while the momentum along the y will flip. It becomes double of this basically. Okay, so if you figure out the y component is what is changing. See, x is along the x axis, it's moving forward, but along the y axis, it comes down and it's moving up. So this is the scenario. And yeah, that's it. So you can pause and have a look.